Hello, my name is Evil Genius, MD, and I am here to teach you Newton's first and second laws. I am going to summon Newton from this time machine in 5, 4, 3, 2, 1. Whoa! Sir Isaac Newton.
You know my name?
Yes.
Who are you?
I am Dr. Evil Genius, MD.
Where am I?
This is 2013.
The future?
Yes.
I come to you from the year 1687, after just publishing my studies on universal gravitation in my book entitled Principia. Actually, I first started studying gravitation in the year 1667. Ah, that was such a year. My university was shut down due to cases of the plague. I had to return home to Woolsthorpe to live with my mother. She wouldn't let me out of the house much, so instead of the year of adventure and fun that I was hoping for, I ended up spending a summer inventing the calculus and some physicsy stuff. I guess I could talk with you about some physics. How about my first and second laws of motion? No better place to start than with the first law. My first law of motion goes over the idea of something called inertia. This states that an object that is in motion will continue to stay in motion unless acted upon by an outside force. This is also true for an object at rest. It will remain at rest until acted upon by an outside force. An important thing to note is the mass of the object. This mass will determine the amount of inertia that an object has. Some examples of inertia include pulling a tablecloth out from under a dish. The dishes should still remain if properly performed. Seatbelts used while in a car crash. Now on to the second law. My second law states that the force is equal to mass times acceleration. As you may know it, F equals ma. This can also be written as acceleration is equal to force divided by mass, or A equals F over m. Mass is measured in kilograms and determines how much matter. This is different from weight because weight is how much force of gravity acting on an object is. From this equation, F equals ma, we can say that force and mass are directly proportional. Force and acceleration are directly proportional, and mass and acceleration are indirectly proportional. All the numbers and the formulas and everything is happening, business, math.
Sir Isaac,
What?
isn't this getting a little bit boring?
Boring? Physics? No way.
I think we should fix to something a little more exciting.
What do you propose?
How about a song?
A song? Can there be dancing involved?
Perhaps there will be.
Perhaps! Yay!
Let's get down to business to learn the laws. Did they send me dunces when I asked for brains? You're the saddest bunch I ever met, but you can bet before we're through. Ladies, I'll teach some laws to you. Inertia is the first law that you must learn. If there's no force added, the speed of an object will not change. If an object is not in motion yet, rest assured it'll stay at rest. Somehow I'll make a physicist out of you. If it already has velocity, then it will stay that way. There's nothing that can change its motion except for force. Because I feel is cool for not learning about this. And I really wish that I did a second law. In my second law, I saw that force applied to an object is directly proportional to its acceleration. Force is equal to mass times acceleration. This really is intense, mysterious as towards us till your midterms arrive. Study both these laws and you might survive. Just remember objects can't change without force, and that F is equal to ma. How could I make a physicist? When you are dealing with problems involving friction, you can let the force of friction using Newton's normal force. And when you know the force of friction, you can find the acceleration the object experiences. Firstly, don't forget all about inertia, and that force equals m times a. Now we hope that this video has been informative and that you'll find this knowledge lights your life.
When using problems involving friction, it is important to remember that the force of friction always opposes motion. For example, if I'm trying to pull this box across the table, the force of friction between the box and the table will oppose my motion. It will never help me pull this across the table. So the force exerted by my arms must more than compensate for the force of friction that the box and the table are supplying. So let's say, for example, that this box is 5 kilograms. The formula for the force of friction is that the force of friction is equal to mu, the coefficient of friction, times the normal force. Now, I'll have you remember that the normal force is equal to the weight of the object multiplied by the acceleration of gravity. So if this box is 5 kilograms and the acceleration of gravity is approximately equal to 10 meters per second squared, then normal force will be equal to 50 newtons. Therefore, if I am trying to pull this across the table, and we know that, I'll just give you this given, that the coefficient of friction is equal to 0.1, then the force that I must exert in this box must be greater than 0.1 times 50. So it must be greater than 5 newtons in order for me to successfully pull this box across the table. And there ends our lesson on friction.